Hi, my name is Shazwina and my metric number is A20A2011. I will present about the data description. From our discussion, we decide to choose set C for our assignment. The data set is about a life insurance charges with 1,339 observation, and it has 7 variables: age, set, smoker, children, BMI, region, and charges. From this, we know that the data sources is from secondary data that are already given by our lecturers. There are 2 types of variable: qualitative and quantitative variable. Set, smoker, and region is qualitative variable. Age and children is quantitative variable of discrete. BMI and charges is quantitative variable of continuous. Based on scale of measurement, set, smoker, and region can be classified as nominal scale, age and children, interval scale, BMI and charges, ratio scale. The data can be described by using table of cumulative frequency distribution, and then we can arrange it to be grouped data. We decide to make histogram and OGIF for graphical representation. From the table, we can calculate for measure of central tendency, measure of position, and measure of variation. From our discussion, we decide to use 350 random sample by using 3 variables: age, region, and charges, to calculate the value of life insurance charges per year for each age in different regions. So that's all for me. Thank you.
First, we should determine the number of classes. To the power of 9, we get 512, which is more than the data 350. So the number of classes is 9. Then, determine the class width, which is maximum entry minus by minimum entry, and then divided by the number of classes, so we get 5,561.95. After that, we can do the calculation in a table. Here are the table shows the insurance charges for each age in different region. Frequency is the number of a value that sorted into classes that have more than one value. Here we can see that the highest frequency in the first class by as much as 126. The lower frequency is in the sixth class as much as 7. The cumulative frequency of a class is the sum of the frequency for the class and all previous classes. Here we can see that the total of the frequency is 350, which is same equal to the sample size. We use 2 types of graph to represent our data, which is histogram and OGIF. Histogram is a bar graph that represents the frequency distribution of a data set. Here are the histograph from our data. Next, OGIF is a line graph that displays the cumulative frequency if each class at its upper class boundaries. Here are the OGIF from our data.
Okay, numerical descriptive measure. For measure of central tendencies, there are 3, which is median, mode, and mean. First is mean. The mean is the sum of the value of each observation in a data set divided by the number of observation. This is also known as the arithmetic average. We are going to use this formula, and we got the mean of the charges for each age in different region is 14104.31064. Second is median. The median is the middle value in distribution when the values are arranged in ascending or descending order. By using this formula, we got about 50% of the charges are below 9727.14, and the other 50% of the charges are above 9727.14. Third is mode. Mode is the data entry that occurs with the greatest frequency, and after we are find out our greatest frequency, and by using this formula, the highest mode for charges for each age in different region is 5462.974. For a measure of position, we need to find out Q1 and Q3 by using this formula. the difference between Q3 and Q1 is n for Q3 must multiple with 3 first. After we got answer for Q1 and Q3, then we can calculate interquartile range, which is Q3 minus Q1, and we got 10979.663. For measure of variation, there is 3. First is range, second is variance, and third is standard deviation. Okay, first is range. To calculate range, we are going to use this formula, which is maximum data entry minus minimum data entry, and we got the range of charges for each age in different region is 50057.55. Second is variance. So we are going to use this formula for sample variance. So after we put it our item in this sample, we got the sample variance of charges for each age in different region is 156,631,544.8. Third is standard deviation. So we are going to use this formula, which is sample standard deviation sample. After we calculate for variance, the answer for variance we are going to use and put it on this formula, and we got the sample of standard deviation of charges for each age in different region is 12515.25.
The mean using SPPS for age and radiation number statistic is 13908.8192. Will the mean use manual calculate is 14104.31064. SPPS is 9719.3053. Will using manual is 9727.14. The mood which using SPPS is 1137.01. Will using manual 5462.974. The difference of variant is above 2106777.1. The reach minimum and maximum value for SPPS calculate and manual calculate equivalent to 50057.55 and 1137.101 and 51194.56 relation. The person using SPPS are one quality 4829.9487 and 3/3 qualities 18979.5389. Will using manual calculation, one quality 7176.94 and 3/3 qualities 18156.603.
Now, I will explain the hypothesis testing. Hypothesis testing is a statistical reasoning technique used to determine whether a difference between a sample and a population is due to sampling error of significant difference. In this assignment, I use two methods such as t-test and ANOVA. First, I will explain the steps of using the t-test calculation. Step 1. State null and alternate hypothesis. H0 U equal H plus region. H alpha U not equal H plus region. Step 2. State the level of significance. 0.05. Step 3. SPS output. This is the table I got from calculations using SPS. Step 4. Deletion rule. Reject S0 if T higher than T alpha divide to DF. Critical region 2.2511. Step 5. Making a decision and forming a conclusion. Since T higher than T alpha divide to DF, then we will reject S0. Therefore, we can conclude that there is a significant difference between the H and region means. Second, I will explain the steps of using the ANOVA conclusion. Step 1. State null and alternate hypothesis. S0 equal U1 equal U2. H alpha, at least one of the means is different from the others. Step 2. Significant level 0.05. Step 3. SPS output. This is the table I got from calculations using SPS. Step 4. Decision rule. Reject H0 if F higher than F alpha V1 V2. Critical region 1.4078. Step 5. Making a decision and forming conclusion. Fail to reject S0 since F higher than F alpha V1 V2. Therefore, there is a significant difference among the treatments.
Correlation analysis. Step 1. The direction. The positive and negative signs show the direction of the relationship between age and charge. From the table above, we can see the percent correlation R between age and charges is 0.318 which has a positive sign will the p-value or sign value is 0. Make sure that the decretion and degree of straight line relationship between two variables which are age and charge. From the specular maps above, we can see that as age increase, charge increase as well. Step 3. The degree of relationship to straight. The value of person, product, more direction are indicates a level of correlation between age and charge. It have a value in the range of -1, a small 1, which is 0.318. First, a value of R, H1 is a strong negative correlation between the two variables. 2. A value of R needs +1 in place of a strong positive correlation between the two variables. 3. A value of R reads 0 in place there is little or not correlation between the two variables. 4. A value of R equal 1 in place that is a perfect correlation.
Next, I will explain the confidence interval. Confidence intervals are intervals for estimates of all parameters based on sample statistics. This is a table I got from conclusions using SPSS. When using SPSS, the above results show a lower bound 12,584.2835 and upper bound 15,233.3549. Therefore, we can say that 95% are confident that the population parameter is between 12,584.2835 and 15,233.3549.
My name is Naida Shafika binti Roslan and my metric number is A20A1805. To do prediction modeling, we use the equation of multiple linear regression. Here is our scatter plot matrix between age, region, and charges. The R values of charges have significant correlation with age, while region is not. The R value between region and age is very low. Perhaps there is no problem of multicollinearity. Next, test of normality. Since our sample size is 350, which is greater than 30, the Kolmogorov-Smirnov test will be most appropriate to use. The p-value is less than 0.05, thus the assumption of normality of the residual terms is not met. Model summary. For R square, 10.3% of the variation in charges can be explained by age and region, while for adjusted R square, it is 9.8%. The Durbin-Watson statistic is far from 2, indicates there is serial correlation. ANOVA, the p-value is less than 0.001, indicates at least one of the two variables can be used to model charges. Coefficient, here is the equation for our project. For every unit increase in age, charges will increase by 279.526, provided the resident region remains unchanged. For every unit increase in region, charges will decrease by 455.656, provided the resident age is still the same. Based on standardized beta coefficient, the effect of age is higher than region. The p-value for age is 0, which is less than 0.05, so age is a significant predictor of charges, unlike region. The 95% confidence interval for age does not fall within the interval, indicates age is a significant predictor of charges, in contrast of region. The VIF values are under 5, which means that there is no problem of multicollinearity. That's all from me, thank you. Next, Nabila will give a conclusion of our project.
Okay, the last one is conclusion. From our report that statistical we had done by our data with 350 samples including 3 variables, which is age, region, and charges. For our graphical representation, we use histogram and OGIF because our data is quantitative data. For numerical descriptive measures, we use SPSS system to compare the value that we got from manually calculated. There have a difference in mean, median, mode, standard deviation, variance, quarter 1 and quarter 3, but no difference in maximum and minimum data entry. In hypothesis testing, first we use sample t-test to conclude that mean is not equal to age and region. Then we got there is significant difference among the treatments by using ANOVA test. We also perform correlation analysis by scatter plot and correlation table. We got a conclude there is correlation between age, radiation and charges because R value is less than 0.3. Besides, we constructed a theoretical regression model of multiple linear regression. By refer to model summary from SPSS output, we conclude that 10.3% of the variance in charges can be explained by age and radiation. From ANOVA table, we conclude that we can use at least one of variables, which is age and radiation, as model charges because p-value is less than 0.01. Last but least, from the SPSS output of coefficients, we got the equation charges equal to 4043.477 plus 200 and 79.526H minus 455.656 radiation.